So good afternoon, everyone, and welcome to the academic training series. Here, we will have our second lecture. But before to start the usual introduction, I would like to remind you that at the end of the lecture, we will have the opportunity to ask questions to our speakers. You can raise your hands via Zoom, and I will give you the turn, or write the questions in the chats and I will read them, okay? And then Maria and Nathaniel will answer your questions. So as you could read in this lecture of today, we will have Maria and Nathaniel that will explain how the multi-purpose internet mail extensions were introduced more than plain text in email messages, and how was the web at CERN during the first decade of its life. As many of you know, Maria Dimou studied physics in Athens, and after 5 years of work in IBM, she joined to a research project, a new research project that was called Eureka. Meanwhile, she was as well studying computing in Brussels. At CERN, she was responsible of many things. First, for the mail gateway configuration, and contributed to the definition of the X500 directory protocols, also the network topology, web support. She was during 13 years participating in the WLCG, the Worldwide LLC Computing Grid. And she is the main chair of the academic training committee and leads the CERN Solid collaboration. So I'm very happy indeed to introduce Maria, but also let me introduce our second speaker, Nathaniel Borinstein, who is in the University of Michigan and chief scientist of Mimecast. He has been, internet researcher, activist, standard maker, and interpreter since the 80s. And he is very, he is the co-creator of the MIME standard, and he is called like the father of the email attachment. So you can imagine that he is the right person to talk about that in this lecture. And he has founded 4 companies, was an IBM distinguished engineer in charge of research and standards for the Lotus division, and also the author of 3 books and 21 patents. So and also just to let you know that he remains wildly optimistic. That sentence, when I read it, it was fun, but okay. That the internet will do more good than harm, and I believe that as well. So please join me to welcome Maria and Nathaniel. Now the floor is yours.
Thank you very much, Mary. Thank you so much. I hope my sound remains audible. Yes, I see at a reasonable level. And I will share screen now. And let me just go to the beginning of this talk. I just want to know if this is full screen for you. Is it full screen for everybody?
Yes, it is. Yes, it looks
good. Thank you. Thank you so much. So we have a lot of material, Nathaniel and myself, and this is why we kindly ask you to go to discuss everything in the end. The parts will be email, MIME, web. Of course, there is no illusion that the 33 years of the web and the 43 of email can be covered in less than an hour. This is why there are a lot of links, both in the slides and from our Indico event, that it will be fun to visit if you are interested. For example, I dropped the hyphen years ago because I read this article by Donald Knuth that you have linked from here, where he had a strong opinion about why it's pointless to write e-mail anymore. And this is an interesting article because the very famous author and professor of semiology, Umberto Eco, is being interviewed by the New York Times, where he says why his purpose in life is not to be contacted. And this is why he doesn't have any email. It's fun to read. So we are not going to talk about the bleeding edge of technology of today. We are going to cover the late 80s and the early 90s concerning the mail specifically. And this is why the series is called Historical Perspective. As we have started seeing yesterday, but we hadn't coordinated with Ben on slides creation, so there is some overlap, but the emphasis, I hope, will be different and still interesting for you to follow. So the situation with the network in that period was that creativity and liberty was present in the internet world. Regulation and hierarchy were the values of European networking. No judgment on these terms, but I just wanted to emphasize what was going on. So we will discuss the email gateway at CERN before the Microsoft contract, which introduced the Exchange, Outlook, and so forth at the end of the 90s. There is a general and principal question of what was the motivation to create this series and why talk about the past. The quote that Tim Berners-Lee often uses in the solid development channels is that we have to know why we did what we did and how we did it. It's sort of change theory. This helps us to select future choices that actually do work. Of course, the required prerequisites for making a change that is desirable or unavoidable, or both, is that we have to agree on what actually does work, and we have to collect proof and share common values in order to decide. And then we have to have the willingness to accept a certain work culture and ethic. For example, backwards compatibility and decision-making by consensus is very important, especially in research environments like ours, where people work much more than 8 hours per day and they need to be creators of their own projects. This is a photo of a book of also the 80s, but apparently I found out that it was first printed in 1970. That impressed me because, first of all, it is still read today. I don't know by who, computer archaeologists. And it contained lists or about 500 pages to explain presumably everything about computers, the Penguin Dictionary of Computers by Chandler, Graham, and Williamson. Why do I put this here? Because I wanted to remind everybody that the people who were doing computing in that era, late 80s, for example, but surely before as well, we were all mathematicians, physicists, engineers. And therefore, it's not that the computing knowledge or interest or value of development was lesser, not at all. Yesterday, Ben explained how one or two people created the greatest and longest living achievements in computing history. But I just wanted to emphasize that at that time, not only regulation, not only hierarchy, but also a kind of theoretical thought was very present in the development, something which which sometimes new developers are less focusing on and more focusing on what actually works very fast. Now I have two slides that are entirely thanks to Vint Cerf, and I thank him so much for all the advice throughout the years and also for being here yesterday and today. This is how he explained to us in 2009 when he visited CERN and gave a talk of the early days of the internet. The packet radio van that was circulating across the various nodes when the signal was becoming more weak. I'm sure at the end, Vint will explain this in a more fascinating way, but just to show you how they were sitting inside, Vint and his co-students, and driving to the next relay. And this is also the van. It is so impressive for us. I guess the younger people, if any younger people joined, must be also at awe before this way to actually do things. And now I have also another table I would like to show you in the next slide. Please observe, it's a list of countries and they are networking connectivity. The countries which have an X in 1993, Internet Society News Magazine, they have absolutely no international connectivity, something that even to me seems unthinkable today. And most of those which have something, countries I mean, they only have email connectivity. So this is the table. Look how many X's one can see, therefore how many countries with nothing at all. And you have here the legend. With email only, they are also quite a lot. So if you subtract them, there's little left. So now coming to CERN, how was CERN in the 80s? Yesterday, Tim Berners-Lee was connected and he said about the same thing. But I have put here the extract of the proceedings of a conference where he was here and gave a talk in 2003, where he said CERN was an exciting place to be for the computer scientists in the 80s, with many information systems on different computers, on different networks, all incompatible. So the idea was for the web to devise a means to be able to communicate and share information. Yesterday, Ben said it with emphasis and proof and very well, how much incompatibility was reigning. So here, coming to the European network landscape, we had a Eureka European project called COSIGN, which was supposed to promote the OSI standards. And I was working just before I came to CERN, after IBM, for this rare organization that was supposed to form working groups and promote these standards and encourage implementations. So I've put here all the acronyms, Cooperation for Open System Interconnection. It was to create a network infrastructure based on these OSI protocols that would be for research and development, not only for academic, but also for the commercial community, totally European focused. So there were 19 countries nevertheless, and the Commission was funding. That was 96 that it was created, and it had many working groups. In some of them, for example, Working Group 3, I was representing CERN for email and directory services. We shall see how important directory services were, and Tim Berners-Lee for information services, what afterwards became the first forum to try his code for the web. So Ben mentioned a little bit the open systems interconnect with the 7 layers. The network protocols of 7 layers, they had, you can see here from the physical layer, the cable up to the application layer where one can imagine, for example, the email, the most successful application at the time. It was supported by CCITT, very influential organization that afterwards became the ITU of today, the International Telecommunication Union. Needless to say that the debate was around the transport layer, layer 4, 3 and 4, because there it was where TCP/IP was, as Ben so well explained, winner and simple and working out of the box, and where this was very procedural and the implementations were slow. The standards that were very much sort of the most successful were X25, sort of layer 3 in that model for the packet switching on the wide area networks. X29 for remote terminal access. At that time, we didn't have laptops, so not everybody. X400, the protocol for email, where we were very much invested, also here. X500, the directory service, which was extremely important because it defined the attributes of the X400 addressing scheme. So REA had a French acronym for some reason, Réseau Associé pour la Recherche Européenne, also funded in 1986. First office was at NICEF, for those who are physicists in Amsterdam. That's where I was working. My boss was James Hutton, who joined the JANET network, the UK research network afterwards. And you recently followed an academic training lecture by Eric Hauser, with whom we were working at the time, who is the head of GEAN. So REA became various other acronyms in the middle until today. What do we want to say about all these European organizations with the EU support and funding, etc.? There was really a political will, it was very political indeed, to have European network standards. The PTTs at the time, I don't know, 1987, were omnipresent and very powerful. The state monopolies, therefore, were also the ones that thought that they will regulate everything about networking, like with telephone. Every community, large community, like the high energy physics community, and every group of collaborating countries like Nordunet for the Scandinavian countries, had their own network or set of networks. And some of them were proprietary. For example, the HEPNet was very much dominated by DECnet, what we said yesterday of the Digital Equipment Corporation, a company that no more exists. And every country had its own network, Aconet for Austria, Red Iris for Spain, Ariadne for Greece. I've put there some examples to keep it short, but I just want to explain that in the working groups of REA, everything concerning status, underlying technology, content information, etc., was all written and published on paper every few months. And the working groups were working on evolving and putting pressure for implementations or trying new implementations. So we had, in the high energy physics, we had the HEPNet Technical Committee. And at some stage, the HEPNet Technical Committee subgroups contained a mail group of which I was chair. So everything that was so important for us, for the network, was regulated, sort of managed, coordinated by these committees. Now there is an extract of a magazine that no more exists. At that time, 93, was only printed on paper. Now the site exists, but they haven't kept their archives, which is very funny because it says at some stage in the US, it's an article about the US, a messaging architecture of the Clinton White House takes shape. It says still such high profile usage by the world leaders' staff is bound to have its effects. The time will come soon when world leaders find, store and forward messaging a service as a convenient way to exchange routine correspondence. Anyway, I leave you read the rest and the mentions to Clinton and Al Gore. And I end by showing you the X400 syntax of the USA White House. X400 users could write to the White House, country equals US, administrative management domain MCI, surname White House. And the rest is also very interesting and amusing. So how did this story resolve? The OSI protocol, transport protocol, was not as efficient as TCP/IP as we said. OSI would need many years to become mature. Performance and functionality requirements were pressing. One could, although it's not similar because now the European anti-GAFAM struggles, big company struggles, are about paying taxes or something. But one could say at some stage a little bit that they wanted to maintain a European identity in research and development in networking, sort of an excuse for, I sympathize sort of, I don't say that it's an unjustifiable excuse, but it is a motive that dominated at the time. And the wind started to change in '89, where TCP/IP and internet applications were open and they existed already, and they were performant and they were easy to use. So it was obvious. So I'll go quickly through some pictures. At the time we were drawing on plastic sheets, as you can imagine, that show the CERN gateway. You can see the CERN gateway in bubbles that are various hosts, physical machines, and the types of protocols that were converted in there. MINT stands for mail interchange. EAN was the first X400 implementation. You can see Priam was a Unix machine, and you have various manufacturers that no more exist, the Apollos, the Suns, the DEX, and so on. And you see the various protocols, how they go from one to the other to get converted. So I'll go very quickly to the subsequent years that I was still responsible. 1990, you see that we have a very subtle, as we go ahead, a simplification of the whole picture, but really very slow simplification because we were still insisting on maintaining X400 by all cost, and many of our research partners were either on BitNet, IBM Networks, DEC Networks, and so on. 91, this is how it looked, not very different. The CERN site, that was an Altrix machine, DXMint, still a VMS machine, VXGift. Here the various workstations that were already introduced, where in each workstation there was its own mail client, and we had to make sure in the user guide that they were all able to display, no matter from which protocol the mail originates. 92, significantly simpler, and then basically we abolished X400. Look how the addresses looked. This is very difficult for today's people who understand the SMTP and RFC822 to imagine that one would have an address sort of looking like this. And in X400, one would have an address looking like this. And you can imagine here, while the X500 attributes were so important, because who owns the administrative domain and how the private management domain is called and which is the organization was important to decide. It was worldwide valid, as we also said yesterday. This is a paper that I have linked from here at the end, the full paper, where Vint Cerf, in his first visit to CERN, at least the first visit where I met him, he kindly gave a very detailed comments on the proposed naming structure for directory services paper that I had written at the time. The paper is in the CERN document server, and you are encouraged to read it with Vint's comments and in its final version. We said a little bit about attributes. I'll go quickly. Which attributes to adopt and which is the authorities that gives values to the attributes, as you can imagine, is like giving somebody a name or giving somebody a passport or something. And how deep is this hierarchy was also very important, and also technically very important, because in the rewriting rules between, for example, Unix mail and X400 mail, the intermediate attributes had to be grouped in local tables, handwritten tables all the time. This is why the X500 work was very important, and at the end, X500 was a useful piece of work, because today's LDAP and today's X509 attributes in digital certificates are using these principles. Here we have another historical email where you can see, sorry, I exited full screen now. I should be full screen again. Tim Berners-Lee working on the, sorry, if I move, I get the full screen undone. Is it full screen now? Yes. Tim Berners-Lee in his next machine, the one that we discussed yesterday, how difficult it was to purchase because it was expensive, he writes to the working group of the RARE organization on directory services and information services. And please observe what he says. In the functional specification of the being designed information services, the web did not exist at all. We are talking sort of 91, where he was at the end of his development. And the international community didn't know. So he writes, we should, one might want to use the data as part of a hypertext system, which would encourage their inclusion out of foresight. And also later he says the philosophy that the server should be central is suspicious. No facility should regard itself as central, etc. So please look at it offline. I put it here because it shows the email addressing scheme, timbl at nx next OC online computing 01, the first next ever purchase, .cern.ch. The host was part of the address at that time. So there he mentions also the use of HTML, that was the inspiration for HTML, etc. These are very important emails. And he gave his consent, of course, that I use it here. And that address is no more valid, so we don't have GDPR issues from this point of view. Of course, the web made all this work of coordination of these working groups infinitely easier, because all these catalogs of services we had to maintain were not any more necessary. And the contents of these catalogs could be updated in a much more easily maintainable way. And nevertheless, it just shows that before the web, there were so many things that had to be done manually and via meetings and stuff like this. So what we did was basically via send mail configuration file regular expressions. When SMTP and RFC822 were in, everything in terms of performance improved. We had an email interface to everything. For example, one of tomorrow's speakers wrote the electronic mail directory that was a way to to query the CERN People's Directory via email. I have a picture of this. And in 93 only, I had a summer student, George Melisargos, who was here for 2 months, and he wrote the autorouter program in C. At that time, we had manually to map a username at host or domain to something which is first name dot surname at cern.ch. At that time, first name was optional, not mandatory, unless the disambiguation was necessary. So this is an example of how one could query the CERN directory. One sends an email and receives the results in the email body. You have the instructions there on how to address the specific CERN dir address and the specific subject that you need in order to obtain CERN directory information. So the team was very small concerning the email gateway of the time, despite the many protocols. Denise was running it until 88 that I came here. I had one fellow, Thor Bothner, who was helping very much technically. Bottlenecks due to the store and forward in every single relay, let's say, host were phenomenal. And the greatest fear and the most frequent problem were the loops. And we had a colleague, the wisest guru of Unix, who was the magus, Dietrich Wiegand. He was reading the core dumps of the machines like mystery novels. He could find exactly the character that would explain the problem. So all of what you saw, the incompatibility of network solutions and the address syntax continues reworking all the time and rewriting were the basic challenges. On the contrary, we did not have spam, phishing, security issues that are now the most important concern. And I was impressed to read in this flyer of Terena, today, Jean, that the first large-scale commercial email spam on the internet only appeared in 1994. So at that time, look at this article of February 1991. Somebody comes back from vacation and the messages are in a terrible mess due to loops. So the newspaper, The Independent, in its science column with the title Shortcut to Chaos, was saying that email leads to chain reactions that create havoc in computer networks. So to wrap up, there was a lot of heterogeneity. This is also Tim Berners-Lee that said in the same talk in 2003. Now, heterogeneity was a good thing because diversity is a good thing. It's good to have a variety of types of computer and operating system in large organizations like CERN, etc., etc. So he explains why that was also a motivation to create the web. And also coming to issues of society. Look at this extract of the LBL laboratory in Berkeley. In December 1990, somebody writes, I've been trying to connect to a computer in the Soviet Union. I was given the following address, PSI, and all this crazy syntax that you have seen for Dubna. And the response of LBL was what? Try VXL, : PSI, etc. Therefore, to put it in the DECnet, via DECnet, in the CERN mail gateway and forward it to the Soviet Union, just to show the bridging role that CERN had at the time between the worlds of different mentalities. And now I would like to introduce Nathaniel, whom I met in a conference. We were talking one after the other. he was speaking about why do people prefer fax to email. And so now I would like to exit the full screen, share the screen with Nathaniel's slides. Tell me if you see the white slides. Can you? Somebody? Nathaniel.
Yes, yes. Thank you, Maria. Yes, this is, I'm honored to be here. Thank you for having me. I actually started in this business. I suspect I was among the first people who came to the internet as computer scientists and regarded it as a fait accompli, and meaning no respect at all to Vint. I thought everything was just completely under control. I heard about TCP/IP, which was coming, and it sounded like the biggest problem would be, 32 bits of address space, and that was not my problem. So I focused from the very beginning on what you could do on top of the internet. And the first thing I ran into on my first day on the internet in 1980 was that there was this cool thing called mail, and you could reach over 100 machines all over the world, but it had problems. And so I've been working on those problems ever since. Next slide, please. So email in the 1980s was very limited. First of all, it was text only with very few exceptions I'll talk about in a moment. All that was standardized was English, in particular 7-bit ASCII. So there were 128 possible characters, and a bunch of those weren't even readable. So this was a problem for like everybody outside the United States, obviously. And there were a lot of different things that were done that were sort of short-term workarounds. If you were in Japan, your computer assumed that you were using a character set that's come to be known as ISO 2022JP. And if you were in Western Europe, you tended to assume 88591. And what happened was that if you traveled and you went to another country and you tried to read your email via Telnet or something, you would see gibberish characters on your screen. It was actually a pretty serious problem. And you didn't have your own laptop back then, so it was actually not trivial just to read your mail from overseas. Meanwhile, there were a few experimental multimedia mail systems, and I heard about some of these ideas and got impassioned. Next slide, please. And I got involved in a project called the Andrew Project at Carnegie Mellon. This was something that IBM provided a whole lot of money to experiment with personal workstations. And it was billed as the academic computing environment of the future. It was very ambitious. And this turned out to be great for playing with advanced email because we had control over the entire campus. This was one of the first campuses that was attached to the internet. We worried about, what undergraduates would do to net news, things like that. But we did have the ability to make sure everybody had the same capabilities. And the Andrew system was built on top of the idea of a global file system, AFS, which still exists, a very rich toolkit and window manager. This was before X11. And then the part I worked on was the email system, which we just threw the kitchen sink at because we had control over everybody's software. We didn't need to worry about whether the person on the other end would be able to read all our most advanced features. So we threw in pictures and sounds and rich text and international languages. And more than that, we threw in animations. We threw in interactive objects like the one you see on your screen. This was an email that when you read it, you could move some dials and order Girl Scout cookies. So this made for great demos in the mid 80s, and we spent too much of our time giving them. One day, Steve Jobs came by and he saw our demos and he reacted the way a lot of people did, which was enthusiastically. He tried to hire every one of us. He did not get a one of us because we'd already heard by then what it was like to work for Steve Jobs. Next slide, please. So he set up a team at Nextmail, where he was then, that built something that was a whole lot like Andrew Messages, which I thought was delightful. I just wanted to see the ideas get out there, but it forced me to confront the fact that his users could send each other pictures and my users could send each other pictures, but they couldn't send them, they couldn't cross that barrier. And the same was true for international languages and sort of anything interesting in email. So that led me to study the problem of interoperation, which I had been fortunately able to ignore in that previous stage. Next slide, please. And there were a whole lot of problems. There was no standard for anything but text, and there was barely a standard for text. Even ASCII wasn't fully standardized. During the MIME work, we spent weeks debating what ASCII meant. And if you look today at email, you'll still see the character set specified as US-ASCII, because not everybody agreed that ASCII unambiguously meant that. So it was a mess, and no rich text standard either. And there were other problems that had to do with email transport. Anything over an 80 character line was prone to wrapping or truncation. Any characters that had the 8th bit could have almost anything happen to them. We still had to worry about converting from ASCII to EBCDIC at gateways to IBM machines and so on. There were just an enormous number of transport related things that had to be addressed. And there were some of us who'd done uninteroperable experiments, like I just said, and wanted to go to the next stage and have a standard. But there were other people who just said, let's throw away all of internet mail and start over. And that came in 2 flavors. There was the people who said X400, because X400 can do anything because it didn't exist yet. And there was Steve Jobs who said, just do what we do. So we looked for a third solution. Next slide, please. And it turned out that there was a convergence of political factors that was very fortunate. There were a whole lot of people worried about the character set issue because you want to be able to send email in your own language. Most of them didn't understand email and the transport problems, but we didn't understand the character set problem. So we became allies very quickly. Some of us, myself included, were focused on making email include any media imaginable. And since that included text in all languages, that was pretty compatible with the first goal. There were other people whose main goal was to simplify gatewaying between systems, which was a nightmare, even though people made nice careers of it. And putting all these goals together made for a standard effort with a lot of momentum. There were a lot of people who wanted to see it succeed for different reasons. And it's worth mentioning someone here, Einar Stefferud, who was one of my mentors. He saw my Andrew demo and introduced me to Ned Fried, who worked in email gateways, and suggested that we collaborate. I believe his exact words were to finish off OSI, or maybe he said to finish off X400, I'm not sure, which was a little overstated, but, and I, coming into this strictly from an email perspective, I barely knew what OSI was. I thought the internet was what Vint Cerf said it was. So I sort of became an accidental dragon slayer in that regard. Next slide, please. So what we ended up with is called MIME. It's the multi-purpose internet mail extensions. I stress that last M since it's used mostly outside of mail nowadays. The goal was to solve all the problems I just mentioned with complete backwards compatibility. That meant tremendously complicated encodings for transport across gateways and even worse encodings for headers. But it also meant a namespace and registry for media types. And that's the part that became much more widely influential. There was a lot of debate, and we ended up with a 2-tier structure in which the first level of the naming indicates the general type of media, and the second goes into detail. And that turned out to be useful because there were things like general image viewers. So if you got an image in a format you didn't recognize, you could pass it to that and hope for the best. So people were playing with this for a little while. I sent out what is often called the first attachment. That's not quite accurate, but it was probably the first MIME message that was interesting. Is probably a better way to describe it. This was sent in 1992, as you can see. I was singing at that point with, I was at Bell Communications Research, and we had a chorus called the Dial Tones, and I had a quartet called the Telephone Chords. And this is the telephone chords singing, let me send you email to the tune of Let Me Call You Sweetheart. And I'm not going to play it for you now, but it's available on the Indico page for this if you want to hear it. This is, in my entire singing career, I'm sure this is my high point, and I miss the high note, so you can enjoy that. Next slide, please. So what happened next was kind of remarkable. Essentially, all mail programs that had any chance of surviving moved to MIME within the next year. We made a version of Andrew that sent out MIME. Nextmail was pretty quickly doing MIME. Next slide, please. And one technique that I think is worth mentioning that I think really hastened the adoption was I built an open source package called MetaMail, which was designed as a standalone program to be called by your mail reader to figure out a way to display a MIME object. And this allowed us to plug in MIME support to every existing mail reader very quickly. It defined something called a mailcat file, which basically just mapped a MIME type onto a program that could show it. This was sort of adopted worldwide into every major mail reader within weeks. So at that point, my wildest dream had been fulfilled. And it just kept going. The code was gradually cannibalized to the point where nobody maintains MetaMail anymore, but its code lives on in lots of places. And within 10 days after releasing it, I got patches to make it work on 1 million versions of Unix. And I had just done it on one, and DOS, Mac, Amiga, VMS. I had the feeling I was onto something. Next slide, please. Then came a very lucky day for me. I got a phone call from someone at CERN saying, we've heard about MIME. At this point, the World Wide Web was text only. Do you think it would work for the World Wide Web? And I, being an email guy with my head down for the last 15 years or so, said, what's the World Wide Web? So they explained it to me, and I said, oh, that sounds neat. And now MIME is used quadrillions of times daily for the World Wide Web, and I deserve no credit for it at all. I was just totally lucky in that regard. Next slide, please. About this time, Maria Dimou, our host, was spreading the word about MIME at CERN, and I couldn't resist putting this slide up where she was explaining the structure of MIME, and obviously hadn't yet been brought into the world of PowerPoint. So this is my marker for how old MIME really is. Next slide, please. Just one last bit about what MIME has grown into. When we defined it in 1992, there were 16 MIME types. There are over 1,600 today. The top level types have been included. We knew there would be a few more probably, but there have been a couple more. There's a top level type for matter now, which you might think of matter transport a la Star Trek, but it's also for 3D printing instructions. It's also a great way to smuggle illegal drugs. If you have a machine that can synthesize them from a chemical description, you can basically send LSD through email. And there's legal issues, but free speech also applies. So it's certainly extended in ways we didn't expect. And it provided an easy way to register proprietary formats. There was a lot of debate on that. There were people who said, oh, there should be nothing proprietary on the internet, with which I agreed and said there should also be no death in the world. So this, at least MIME provided a way to register it so that when you get a proprietary type, at least you have a chance of mapping it onto the kind of data it actually is. And so it's evolved into the common naming scheme for global media interoperation. And with that, I'll hand things back to Maria.
Gosh, thank you. Am I still audible?
Yes.
Thank you. That was fascinating. Oh my God, the story about the new types. So I will have less slides here. And despite the vast material of the web, or because of the vast material about the web, and I'll try to be faster so that we have time for discussion. So we're going to talk about basically the first 10 years of the web and what happened to it and how we get out of the situation with the web today. So you see in the next picture the proposals that Tim Berners-Lee had to submit and resubmit and resubmit. The links to the full text is available from these links. As we said yesterday, everything that was not related to physics computing was off. So these are the picture of these papers, giant print in the computer center entrance at CERN, show that we are happy now. You see these graphs. I don't say they were inspired by Tim from the mail gateway, but they just show that there were different, absolutely different manufacturers and different operating systems. At that time, the CERN IT was called Data and Documents. So documents was important part of the identity of the department. It was called division then. And this is why there was a lot of discussion and working groups about documents and document formats. This is also a very amusing extract of the 1992 CERN annual report, where Tim went to San Antonio in Texas to explain the web. There is a next there on the desk. And it's funny because the article at some stage says, until recently, physicists were confronted with an irritating jumble of network protocols, file formats, operating systems, and so on. And it publicizes the CERN-developed World Wide Web based on hypertext, and I'll let you read the rest afterwards. So after Tim invented the web, and he insisted regularly that it is a free, open, networked internet application, and the web created this unprecedented change to human civilization. Today, this year in March, we celebrated 33 years of its life. And the original purpose of access to knowledge, free for all, and respecting each other has suffered a lot because of commercial, political, military, and criminal abuse. So here is another historical email by Tim to me and co-authors of a paper that was called Document Interchange Possibilities at CERN. At that time, we are talking about 1993, FTP, File Transfer Protocol, was the highest, most used in internet traffic. And Tim wrote in April 93, where does www fit in your paper? Well, it fits in naturally before or after FTP, etc., etc. You will see how that it was the moment to encourage www's dissemination and development. So at the first, when he went to MIT in 94, we had the web office headed by Robert Caillot, and I was working there, and we ran the Tim Berners-Lee SMTP daemon. And when we faced performance problems, we switched to Apache. Most of the web servers at CERN were virtual servers defined in the Apache configuration. And then when Unix machines came with Apache, everybody was starting their own web server. We negotiated a free of charge Netscape support contract in exchange of giving feedback to Netscape when Netscape was born. We investigated web-based calendars, recommended hypernews for communication, collaborative work, evaluated a lot of web authoring tools. You can see briefly the conclusions later on in the slides. And we defended Amaya to author web content and slides. To comment on Nathaniel's, I never use PowerPoint. Of course, these are made on the web, these slides. We had two students, excellent students, who did in Java a personal intelligent newspaper agent, which proposed to you every morning links that might interest you based on what you were browsing the day before. And Torch, a natural language processor for web searching by Darek Kogut, my student, who was parsing English language dictionary to understand natural language searching, because at that time the searches required Boolean operators, and people had difficulty to search free format text. So you can see the first web server by Tim is now restored for demo. We had also a website where we were just publishing the tools we are recommending. This was sacrificed at some stage, like many things of the past. And thanks to our colleague, head of the web frameworks, Andreas Wagner, it's now restored. Much of the content is missing. We were very few people. But we did a lot of evaluations, and our focus was that the application would be web accessible. We did not want proprietary applications, and we did not want to have yet another thing to install every 5 minutes. All the data was stored in AFS. I have linked their academic training given by the AFS elders. I believe Jeffrey is connected here today now. It became more popular with simple things like when the CERN phone book appeared on the web, when our colleague Bernd Pollermann wrote a large amount of more than 2,000 questions and answers that were viewable from the web, www.cern.ch/QA, and we were submitting questions and answers by email with the service managers. So I have here a list of events that were important for computing. I don't want to go through them all in interest of discussion, but it is important a little bit to see the moments when DNS was invented, when the Apple Macintosh was invented, 83, 84, 85, Microsoft was founded, and then the same year, Richard Stallman created this Free Software Foundation, 86, the first laptops, 89, the web proposal, and the fall of the Berlin Wall, and the start of the Large Electron Positron Collider, the previous accelerator of CERN, which had intense data requirements. 1990, when the Next was purchased, when Nicola Pellow started writing the line mode web browser. 91, the first release of the web at CERN. Paul Kuntz brings it to Slack, and so it goes to the US. It stops being a European phenomenon. 92, more than 1 million internet hosts, and several web browsers now, not only by CERN, but also University of California, Slack, etc. 93, when CERN puts the web software in the public domain, at the same time the birth of Mosaic, an invitation for Tim Berners-Lee at Fermilab. 94, the birth of Netscape, the first web conference in May at CERN, the end of web development at CERN, the hiring of Tim by Vertusos at MIT, the foundation of Web Consortium at MIT by Tim Berners-Lee and INRIA, because CERN didn't know how to run a consortia other than related to physics hardware, which was the core knowledge of the laboratory. 97, Robert Caillot, head of the web office at CERN, estimates 650,000 websites worldwide. So you see how it rose after that point totally exponentially. Here, an important email that I got from an article that Bibo White, who is with us today, I believe, the World Wide Web and High Energy Physics is his article, and he quotes 1998 State of the Union address where Bill Clinton says to the Congress that the first time he made the State of Union speech, only a handful of physicists used the World Wide Web. Literally a handful of people. Now it is in schools, libraries, etc., etc. So the exponential growth. Continuing with the key events, 2001, first iPod and the 9/11 events. Skype Foundation 2003. I skip a few. Suicide of Aaron Swartz, fearing the charges for fraud. And I would like to mention some society changes that are so different then and now. In 2011, Tim Berners-Lee and Gordon Brown, who used to be Prime Minister in the UK, came to Geneva University to discuss the future of the web. And there we were discussing with the audience completely freely if the dominant languages on the web, namely English, are going to cause the disappearance of languages on the planet altogether, whether WikiLeaks was a good thing or a bad thing. And these were things that were debated totally freely, things that today one doesn't very much, either a political correctness or fear of surveillance doesn't dare to discuss. Then 2010 and up to 2018, the harvesting of data by Cambridge Analytica caused a devastation that led Tim Berners-Lee to announce the SOLID project. And I'll say a very few words about the SOLID project. So continuing on society situations then, so political correctness was probably not yet invented term, because look at this magazine of Macworld in 1999, which promotes Dreamweaver as a web authoring tool. In fact, we had recommended Dreamweaver very much because it was adhering to W3C standards, and not because of this. This is the publicity about web authors who love control and love Dreamweaver. So this, I don't know if today one could show in a presentation or in a magazine on technology. So the SOLID project was exactly proposed by Tim Berners-Lee in order to have the user master his or her data. Instead of registering with an application and creating a profile in each application where you want to purchase a shirt or a plane ticket or a concert ticket, you have your information on your pod, that's the term used, and you give consent to outside applications to use it. So typically, there is a presentation that I link from here that explains very well the full spirit of SOLID, and there is also an index of about 49 events that I sponsored in 2 years that I participated in the SOLID project. You are encouraged to look through them. So as a conclusion of today, we understand email and the web were the most successful network applications of the 80s and the 90s. Internet and the web changed the face of the world. Many side effects were negative, and it would be nice that we tackle them, if you wish, during the discussion. This quote I found in one of the numerous articles that are linked from today's event that you can look up after the talk. There can be no serious doubt that in the late 80s and early 90s, an era in world history ended and a new one began, by historian Eric Hobsbawm. So recap, why do we want to talk about the past? To understand why we did what we did and how we did it, but also to avoid to understand that to have the pensée unique, as it's now used across English and French, is dangerous. One should understand that there is not only one way of thinking, one way of doing things, and there shouldn't be one, because if there is only one, then control and abuse becomes easily dangerous. And for the things of the past, a little quote from the Blade Runner that was done in '82, but it starts in November 2019, exactly when the coronavirus started. The replicant says there, "I've seen things you people wouldn't believe. All those moments will be lost in time." And so one of the motivations for this series was for younger colleagues who didn't know and would never find out what was going on in the past. This was the opportunity. Thank you very much. I'm going to stop sharing in order to be able to see everybody. Thank you.
Thank you very much, Maria. Thank you very much, Nathaniel. So I'm checking here in the chat, but I don't see questions. I don't know if...
I think people would like to be unmuted. Now I think it is safe to unmute everybody.
Yes, yes. Pascal told me that it's allowing the people now to speak. So, but maybe in order. So if you want to speak, raise your hand. and then you go. But for the moment, no raised hands.
It's Vint Cerf, and I'm looking for where
Okay.
to raise my hand, and I can't find it.
Don't worry, the floor is yours.
Well, thank you first of all, thank you to Maria for organizing this. Yesterday and today were a stroll down memory lane. But more important, there were many details that I didn't know. And so this today was especially fun. And Nathaniel, I particularly enjoyed some of the Sturm und Drang that you were describing during the MIME episodes. And I hadn't fully appreciated how MIME had penetrated into the web implementation. So that turns out to be very helpful from my point of view. I just want to mention a couple of things. I can't find it now, I'm embarrassed to say, but there was a book that was written by Donna Lynn Adams and Rick Adams, the title of which was something like exclamation point, pound sign, dollar sign, something else, which was those were the symbols that @ sign, I guess, was in there too. They were the symbols that were used to separate different pieces of the source routing of email because of the varying address formats that were being used. So you ended up in the early days, before we all started using the more standard internet mail formats, you had to essentially steer the mail through multiple relays by giving it source routing advice. And the problem with that, of course, is that the source route didn't provide you with the return route necessarily. And so in order to respond to a message, you had to know what the other path was going back. It's amazing that it worked at all. But it certainly was a strong motivation to settle on standards. And for those of you who were part of the email world in the early days of ARPANET will remember RFC 733 and RFC 822 and many of the subsequent standard formats that we use today. I wanted to mention one other thing about Netscape in particular. I had been at ARPA running the internet program, but I left in 1982, late 82, to build MCI Mail, which Maria, you mentioned in one of your slides. And we were very eager in building MCI Mail to be connected to any other email system that was willing to connect to us. So we had a set of protocols that anticipated that there might be different ways of connecting to otherwise isolated email services. And I got permission in 1988 to connect the MCI Mail system to the internet. And at the time, in 1988, there was something called an appropriate use policy, which prevented any interconnection of commercial services with the government-sponsored backbones in the US. And so I was asking for permission to connect the commercial MCI Mail system up, ostensibly to do a technical experiment to see whether we could make the MCI Mail protocol and the internet protocol interwork. But the real reason was to break the appropriate use policy so that we could get commercial traffic onto the government backbones. And astonishingly, I got permission to do that. And shortly after we announced the existence of that mail gateway, the other commercial email service providers like CompuServe and OnTime and Telemail in the US all insisted that they had to get connected to the internet. And the next thing that happens is after they achieve that objective, they discover that all of their customers that they thought were isolated in the walled garden could suddenly talk to all of the other email services through the internet. And so, and it was free, by the way, which is another, kind of a shock. That same year, 1989, of course, 3 commercial internet services pop up. But I wanted to tell you what happened when I rejoined MCI. I left in 86 after doing MCI Mail. I rejoined in 1994 to put them in the internet business. We built 2 big internet backbones, but we decided we were going to build an application that we called MCI Mall, like a shopping mall. This was 1994, way ahead of of what Bezos was doing, who was wildly more successful than we were. So I said, well, we have to build this on the web. And so I went to Netscape Communications in '94. This is just before they went public. And I bought $7 million worth of licenses from Netscape Communications so that we could use their software for both the web browsers and web servers. And then I realized that in the transactions that would ensue, that there would be people who would abandon their interaction. So they might be partway through buying something and then just, kill the web page and go off. And I thought, well, my servers were going to end up with a whole pile of broken transactions. I wouldn't know, when to throw the data away, because the web is sort of stateless and you can come back to continue a transaction. So I didn't know when I could throw things away. So I went to Mark Andreessen, and who was at the time essentially the chief technology officer of Netscape. And I said, I need a way to store partial transactions on the user's computers so that it doesn't end up in my servers. And so he went away and came back with cookies. So if you're wondering where the hell cookies came from, you can blame me and Tim and Mark Andreessen for cookies, which were just supposed to be a way for us to store the state of the transaction on the user's computer. So if the user came back, we could say, hi, you're halfway through a transaction. Would you like to complete it? Of course, now cookies are being used for a variety of other things and everybody hates them. And so now you're seeing efforts like at Google and elsewhere to get rid of third-party cookies and a bunch of other things. Anyway, another little stroll down memory lane. Thank you both again, Nathaniel and Maria, for sharing all this with us and putting it together in such a coherent way. I hope that the people who didn't live through this appreciate the view backward in time.
Thank you. Thank you. So valuable information and so kind comments you always have. It's amazing. The story about the cookies is amazing. Okay.
Actually, I have a question for Vint, if I may.
Yes.
This is just putting together things I just saw, but Maria showed a slide early in the Clinton administration in which the White House was using MCI mail. And I didn't realize that was the case because in 1991, I got involved with the Clinton campaign and I set them up with email and it was not on MCI. I was just wondering if you had a hand in that.
Almost certainly, except I don't have a clear recollection of having done anything. And the reason is that I left the MCI mail project in 1986. And in 1991, I would have been at CNRI with Bob Kahn. However, that was 2 years after we had connected MCI mail up with the internet. So I don't quite know whether the MCI mail folks managed to get to the White House and offer an address of some kind on the MCI mail system, but it's certainly plausible that that could have happened because this is well after the interconnection of the two had been solidified. So I don't think I had a personal engagement there, only a parallel and sort of side connection because of my work on MCI mail and the interconnection with the internet.
Well, I suspect that that AOL didn't put up much of a fight.
Yeah. It's amazing to me how many people still have AOL addresses, and a lot of them are in the security community, which I find to be an oxymoron in some sense, but quite surprising.
Fantastic.
Hey, Maria, this is Bebo. Can I make a comment?
Yes, please.
I want to thank you and Nathaniel and Ben yesterday for such an amazing chronology. There's so many things that I had either forgotten or I never knew, usually the latter in that case. But I especially like it in the context of what you said about history, because you also realize in listening to these presentations, how many rabbit holes people went down and how many obstacles ran into. And, it's just absolutely amazing that finally it works as well as it does.
Yeah.
And you really helped emphasize that. I think that was an incredibly valuable contribution that y'all made.
Thank you, Bibo. It's very kind of you also for your mail yesterday. We do still have a lot of difficulties to get things done in the open source projects we want, etc. It's not a very different. That's why it's nice to see history, because one can get courage that this periodically, not as a circle, but as a spiral, comes back and again and again. So yeah, thank you very much. I wonder if Jeffrey would like to say something, because basically the things that worked perfectly and still work, and the way I found these old emails of historical value were because they were in AFS, you know. So where are you, Jeffrey?
I'm here, Maria. Thank you for inviting me today. I sort of feel that I'm kind of from like the next generation. Kind of missed the 80s. Was in college at the time. Very proud of leveraging email. I remember traveling to Japan in the late 80s and using CompuServe and having to route email messages back to the States via BitNet. And I didn't come to become exposed to the Andrew Project and AFS until 2003, which was very late to the game. And when I came, my observations of it were that AFS and the World Wide Web really were two sides of the same coin. I also had spent a great deal of time in my college days and in the 90s working on the Kermit project. When Nathaniel's discussion of the character set issues, one of the very important aspects of Kermit was not just being able to transfer data across two tin cans and a piece of string, and multiple different kinds of networks grafted together from the US to the Soviet Union, but also doing the live character set translation to make sure that the files would be readable when they got to the destination system. I have never had the opportunity of meeting Vince, but I had always thought that AFS would have been a better backbone for the World Wide Web than HTTP. If only it didn't have the export control problems associated with the crypto and authentication from the late 80s. But again, thank you for the invitation. I definitely appreciate these historical presentations. They are definitely very important to archive for future generations.
Thank you, Jeffrey. Thank you for joining.
So it's been jumping into open microphones again. Just to make a reference to what Jeffrey said about archiving, I'm still very worried, as many of you might know, about digital archiving, because I'm afraid that we won't be able to correctly interpret a lot of these digital formats 100 years from now, or we won't have software that's capable of doing it. It won't run on the operating systems of the day. So I think in addition to all of the problems that Maria alluded to about abuse of the World Wide Web and all of the applications that we built on top of it, I'm still very worried about the digital dark age problem, where our software is no longer runnable in the future, and that lots of digital objects that we would have wanted to retain and have access to and make use of will be unusable. So another very, very tough and very big problem that is as hard to deal with as the ones that we've been talking about for the last couple of days, and certainly deserving of our attention. When I think about CERN in particular, and I think about all of the data that's being collected in the various systems and the quantity of that data, the importance of being able to keep that data usable over significant periods of time is very important because of the possibility of re-examining the data and reanalyzing it. And I want to emphasize that because our new discoveries sometimes lead us to want to look at older data and reinterpret it. This is certainly true for astronomy, where we're beginning to have old data is revealing, thanks to machine learning mechanisms, information we didn't know we had. And oh, by the way, for those of you who didn't see the announcement, there's been a new image made of the core black hole in the middle of our galaxy, and it is absolutely stunning to see what, I mean, it's a lumpy donut. And what that tells you is that the gravitational forces in that region must be just incalculably powerful and scary as hell. And it's a good thing we don't live anywhere in the neighborhood. But a fantastic image, once again, of a black hole.
I think Frederick has the raised hand. Sorry, Nathaniel.
I just wanted to reinforce what Vince said about availability of archiving of old platforms. I lived for over a decade of my life developing and then living my life on the Andrew software. At this point, I have an ancient Sun workstation in my garage that I resuscitate every year or so when I want to get a screen dump or something, and I have no other way to run Andrew. You know, piece of history.
Okay, maybe Frederick, you can go ahead.
Yeah, I think what Vint and Jeffrey say is very important. Digital preservation is really something difficult. I slightly disagree with what Vint has said. For CERN, for the scientific data, this is not that much of a problem because the data is managed. We have copies, we copy data over multiple medias. The programs are adapted. What's much more difficult to do is the unmanaged data. Today, we have lost, because of the web, because of digitalization, a lot of data that was sitting underneath desktop in the offices. I'm always saying, people may disagree, of course, but I'm always saying that digital preservation is much more difficult to do than paper preservation, which stays at least for 1,000 or 2,000 years if we are lucky. My 2 cents here.
Can I ask Vint a problem regarding digital archiving in that sense? Is that, do you see this exclusively as being a computer science problem? Because it really needs to involve a lot more social science disciplines, librarians and historians. It's not just an issue, at least to me, of computer science and computer formats.
Absolutely correct. And you get into questions about intellectual property protection because software that's proprietary, you're not supposed to be using it unless you have a license, but as an archive, you need to have access to it to make sense of the data that you're archiving. There are all kinds of side issues as you imply, and I agree with that. The thing that I find the most disturbing is that often we have objects which are of great historical value to us that were preserved purely by accident. And, you know, I don't consider accident to be a good plan. So I think we need to work on this problem.
Well, I have a comment here. First of all, I don't know, somebody wanted to speak. I shouldn't do the most of that. Nathaniel, you wanted to say something?
I was just going to say, to reinforce again what both of you said, I don't actually teach in a computer science department. I teach in the School of Information, which is what the library school morphed into. And so digital preservation is as important as, you know, algorithms.
Yeah. Yeah. When Vint was giving academic training recently on here at CERN on big data and social media, people asked the question about preservation, and he said, for example, it was very interesting. Vint said, if you want to print the photos of your kids when they were small, print them on paper rather. And it also happens here that we didn't have an archiving policy for software. That is something, for example, Tim Berners-Lee asked when he visited in 98, in 2003 for that conference for the Enquire code. That was the code preceding the web, that was inspired by this 19th century book called Enquire Upon and About and Upon Everything, or Within Everything. And the code was written in VMS, and it was junked. And when I mentioned Bernd Pollermann, who wrote the QAs and the web office sites, etc., nothing is saved from there. Many things that were under afs.ch/project, they are junked. So it's frightening.
Actually, Maria, they are not entirely junked, but we have no right to access that because of GDPR policies.
That's also another thing we should somehow sit down and decide, not here now, but how do we consolidate the necessity to preserve things for history while not getting into trouble with GDPR?
I think this is a very, very good question. I'm looking forward for the answer.
Very nice. We should do a separate brainstorming on this with all our distinguished guests of today involved, if they agree to join. I'm happy to organize. Other comments?
It's Vint. I can't resist pointing out that if you can find Jeff Allman's picture, he's now his head is a black hole. Basically, he's right in the middle of this great backdrop. If you can find his image, that's pretty cool. Thanks, Jeff.
Thanks for mentioning it, Vince.
Your head
Oh,
must be
fantastic! My God, my God, beautiful. Okay. Does it look like a good time to stop here today, given that tomorrow we have another opportunity? You are all welcome to join, where Frederick Hemmer, together with Les Robertson, will talk to us about the Shift and the Grid projects, distributed computing for physics at its best. I don't know, the same time tomorrow.
Thank you for organizing this, Maria.
Thank you very much.
Thank you very much.
Thank you, Maria.
Thank you.
Thank you, Maria.
Okay,
Thanks,
goodbye
Maria.
for
See you
today.
tomorrow.
See you all tomorrow.
See you tomorrow.
Tschüss.